Hey, what's up, guys? It's Locust. I'm back. We're gonna be going over how to make a internal cheat in C++. This might be it's gonna be a little remake of the other video I made, just because I feel like the other video I made was really just trying to tell instead of teaching. So this video is gonna go over more of explaining things and making sure you understand it. I haven't made a video in a long time. I just kind of lost the passion for it. But I'm back. I have a very good educational, very well edited video coming out soon that I'll be working on. But for now, I just want to post something just so you know I'm alive, and something that is going to help people learn. So let's get started, I guess. Let's just go over what I'm going to be doing in the video. So we're going to be using Assault Cube as the game. I'm sure everyone uses this. I usually use a game called Idle Slayer, but I feel like Assault Cube opens our scope because A, it's a 3D game, B, it's a shooter, you know. Even though everyone goes over this, it's just a good game with no anti-cheat that's open source. So very well documented. So we're going to be using Assault Cube, and we have, of course, cheat engine, which is going to be for finding memory addresses and finding pointers. We have extreme injector, which is you should all get, and this is going to be for injecting our DLL, which is going to be very useful for injecting our DLL. And we also have X32 debug. Make sure it's 32 because Assault Cube is a 32-bit game. And this is going to be for debugging stuff like if we find a function that we want to replicate, we're going to use this program in order to view the stack, which I don't know, you might not know what that means, but basically just look inside of the computer in order to find certain parameters for the function. If you don't know any of these words like functions, parameters, I would learn a language. That would probably be the first step. C++ is a pretty, it's got a big learning curve. I would start with an easier language like Python to understand the basics and understand the terms. If you do want to just dive right into this because you want to copy, then you know what? You could do that because I do think it's still a good way to learn and familiarize yourself with terms. So, yeah. But you should definitely learn a language before you do this and learn basic terminology. But I'll just explain what a function is real quick, even though, I won't be going too in depth. A function is something that runs multiple lines of code with only one declaration that takes parameters. So for example, let's say I wanted to bake a cake, right? All the steps of baking a cake, I'd have to write out, like let's say I wanted to do it, I'd have to do all the steps to bake a cake, right? And all those steps to bake a cake would be like nine steps, right? I could do all of those 9 steps in one step and specify what kind of cake type. That's a function. Doing all those 9 steps in one step and defining specific properties. That's basically what a function is. So enough talking, let's get into it. I also have Visual Studio open and also IDA Pro. Now this is a paid program, so I do highly recommend that how should I say this? You go across your own means to get the pro version of this program. That's what I'll say. Hopefully you can get what I'm trying to say, but get this program and get the pro version. I don't recommend buying it, is what I'll say. But the pro version just lets you view the disassembler for reverse engineering the game. It's really helpful. It gives you a guess on function types too, so you don't have to guess if it's a fast call, a standard call, all that. So yeah, this is what we're going to be using IDA Pro. So let's just get started. If you don't have IDA Pro too, you can kind of just watch along with the video and see what I'm doing. It's also very specific to notes. I'm using the latest version of Assault Cube, so that's good to know because static pointers might change locations depending on the version. And of course, IDA is going to be different. So yeah. Anyways, so we have Visual Studio. So make sure you have Visual Studio and have C++ desktop environment downloaded. You're going to want to open Visual Studio, and we are going to be creating a new C++ project. So we're going to go to languages, C++, Platforms is going to be Windows. And then for your project type, you can really choose whatever. You just keep it on all. But the most important thing is we're going to be doing a dynamic linked library because this is internal. The difference between internal and external is you're not actually running the cheat within the game's memory space. So you're not using memory in the game and modifying it from the memory space that your cheat is in. You're modifying it from a Windows environment. So that's external. So you don't have to be in the game's memory space in order to modify it. Instead, you can find the game's memory space and then modify it instead of being in it and already being able to just modify it straight from there. You'd have to do different stuff, like you'd have to use Windows API functions like read process and write process memory, a bunch of extra steps, and usually harder, more, harder. Internal can be harder if there's an anti-cheat. Obviously, we're not using a game that has anti-tamper or any of that, so we don't have to worry about that. But the DLL, just make sure it's in the game's memory space and it can be injected. So that's what we want. So make sure you click that dynamic link library. Next, give it a name. YouTube tutorial. All right, and then we're gonna I would click this so there's not two. It just kind of, it's so, I don't know why they do this. It's really stupid. Just click the checkbox and hit create. Wait for this to finish. I do apologize if this computer is slow. I have two separate stuff. I do all my coding stuff on a laptop now, so I'm actually streaming this from NAS. So I apologize if it's a little slow, but it'll be as fast as it can. So yeah. Okay. So here we have just the basic code, the template code that it gives you whenever you create this. So first we need to actually make this DLL work. So in order to do this, we have to create a thread. Now you might be wondering what a thread is, and I can tell you that. So threads are basically processes that you can create. So the DLL is just so it's in the code that you're running is in the memory space of the game's program. So it's in the game's data, this cheat. And this is basically just making a quote-unquote process within it. So the process, it's not called a process, it's called a thread. It just creates, it just allocates a different, I don't know how to explain this. It's just like, imagine you have an like a process, right? And you create it. And then you can run whatever you want. We just need a thread in order to run our own code. Because without a thread, we're basically don't have a program. So this is just when the process attaches. So when the DLL is separate from the thread. When the DLL attaches, it's going to launch the thread. So when the DLL attaches, it launches our program. There you go. A good explanation. All right. So we're going to create a thread. So how do we create a thread? Well, we're going to use create thread. Very simple. I cannot type. There we go. Create thread. It's a part of process thread API header file. Create thread, and it takes a butt ton of parameters. But before we do those parameters, go ahead right here, right click. We're gonna go to properties, and we're going to do a couple things. So first thing we're gonna do, advanced. Change this Unicode multi-byte. It gets rid of having to put L's, doing different stuff with chars. It's really annoying. So do that. And I think that's everything we need to do. So hit OK. Another thing is change this to 86. 64 64-bit, 86 is 32-bit. Why is it 86 instead of 32? I won't get into that. But yes. Okay, do that. And for create thread, we need to pass arguments. So if you look here, we need security attributes, LP thread attributes, and it's LP, so it's a long pointer, which means it needs to be a pointer. We don't need any of that. We're gonna put null pointer. A null pointer is just like, you know how when you put null, it represents nothing. This represents a pointer that represents nothing. There we go. All right, our next is going to be our stack size. Don't worry about that. Put 0. Next, oh, here we go. Next is going to be our start address. So this is going to be where our, our main thread actually is. So in order to do that, we need to actually create a main thread. So if we're creating a main thread, we're gonna just go right. Okay. So we're gonna do sorry, I'm recording this on Audacity, so I'm trying to okay. We're gonna do D word. What's a D word? 4-byte value. 4-byte Windows value. You could do any 4-byte, really, 4-byte value, but we're using WinAPI for this. So yeah, it should be a D word, because when you're working with Windows, use D word. And we're just gonna call this main thread, and then it takes a module, because that's what we need to define in our create thread, as you see right here. So we're gonna do h module. Let's go over it. So first, actually make it a function, or make it, open it up. Next, we're going just need to know what when in C++, when you define the way you define types, or the way you define variables, is you define the type and then the name, which I know it might be different for stuff like Lua, for example, which is Roblox. Because in Lua, you just don't define a type before it at all. Yes. So now, in here, we can actually pass our thread. But in order to pass our thread, you might see here, we need a LP start routine. And this isn't a long pointer. This is a D word. So what do? We have to convert the type. So you can either use a reinterpret cast, or just do this more unsafe but faster way of casting variables. Put LP thread start routine, and then we're gonna put a thread, which is our function. Alright, next it takes our LP parameter, which is of course our H module, and we got our creation flags. Don't worry about that. And finally, LP thread ID, long pointer, null pointer, and it. There we go. Our thread is created. Yeah, there's our thread. So now our process is made. So anything in here will now run on DLL process batch. Whenever we inject the DLL, anything in here will run. Now it's important to put to return in here, so the program exits after this is done. Yeah, that's just important. Now, if you could do checks if you want to check if stuff actually like attached properly, but for the sake of this video, we're not gonna do it. But for debugging purposes, we will allocate a console. So let's allocate a console. How do we allocate a console? Bam. We have allocated a console. Now, now we've allocated space for a console, we need to do this. We need to do file F, right? I'll tell you why we need to do this in a second, and make sure that you include this. We need to make a file pointer to F because we need to direct the streams in order to get input and output. So we're going to do fray open _s, and this is just going to redirect the stream. So here we have the stream, which is going to be our @f. So now we're going to do that, and we're going to do the file name is going to be con. I think it's con out. It's always got the money sign at the end, $sign. We need to specify that we're going to write to con out, and or not we, but std or it's gonna write to the console. So this is just gonna make it so the output is written to the console. You can copy and paste this because we're gonna do this for con in. This is just for input, and we're gonna do con error for errors, and make sure to change this to std in and std error. There we go. We should have a console now, and we should have a console working. I just want to let you guys know how to actually build. So build solution like this, and it should build successfully. And we're gonna inject it into a salt cube and see if the console opens now. Okay, one succeeded. If you don't know where, if you don't know where it is, if you check that box in the beginning, it should be exactly here. Right click your project, open folder in File Explorer, and then go to debug, and then here it is. Here's your DLL. All right. Copy this. We're gonna go to Extreme Injector, which you should have downloaded. I have everything linked in the description. Everything you need here, except for IDA, because that's paid, in the description if you need it. Process, select a process. It's already on it, but hit select. Go to AC Client, select. Then we're going to just remove that. I was just experimenting earlier, and we're going to paste in that path and open up the DLL and hit inject, and there we go. Injection completed. Here's our console. Here's our console, and obviously our game has not crashed. Yeah, it's not crashed. That's really loud. Apologies. When you do close this, it will crash. We can add, if there's time, I'll add a unattach or whatever it's called, detach. But that will be at a later day or a later time. Yeah, so there's our console. If we want to check, we can do print f. We'll do like you print hello, and also you can also print because this is print f. The good thing about this is you can do C allows you to do like numbers and stuff, so you can print values to this console, because this is technically like just basic C. So check. Print hello 9. Nice. There we go. I want to explain printf because you don't really need to know it for sheet making at all. So yeah. Okay. We're just gonna get rid of this. Actually, we'll keep the printf, and let's just print sheet injected! Exclamation point. Bam. Sounds good. Okay. Let's get to actually cheating. If you ever used Cheat Engine before, you should know what to do. If you watch my other videos, you should know what to do. But I'll give you a full rundown of Cheat Engine. So here we have 3 things. You don't need to know these. This is just open a cheat table, save a cheat table. This is going to be, you're selecting a process to open a cheat table. So we're going to open a salt cube. There we go. So this allows you to scan through memory. What does that mean? Okay. In the game, you see how we have 100 health? That value is stored in memory somewhere, and it can be edited. You see how we have 20 ammo? Stored in memory, can be edited. You see our speed, stored in memory, can be edited. A little more complex, probably, the way they handle stuff. Everything here is stored in memory. Those are values that we can do. Okay. Let's do health. So to do health, we have 100 health. And we need to find a grenade. Or something that can damage us. So if you hit E on your keyboard, you can go into no clip. That's what I like about this. Now I don't can't really move that well, so this is going to be a little harder than if I normally were to be playing, but we're just going to look for a grenade, maybe, if there is a grenade on this. Is there a grenade on this map? Alright, I don't know. There's a grenade on this map, but there's ammo. Let's just change the map. Let's go to player. Search map. Alright, there we go. Let's just go to this map. I'm sure this map has some grenades. It's a grenade. Oh, it's ammo. Okay. There we go. There's a grenade. Okay, so grab a grenade, hit G on your keyboard, throw it, damage yourself, 25, right? Search for 25. Make sure it's 4 bytes. First scan. Bam. All these values are 25. Now we're gonna go and heal ourselves using this conveniently placed heal pack. Now we're at 58. Next scan, 58. Now what just happened is it just scanned for a value of initial value of 25, and now it's scanned for an initial value of 25 that switched to 58, which is gonna be our address. Now there's 2 addresses, and they're both in 2 memory spaces. I'm gonna assume that the top one's gonna be our address. Let's see if I'm right. I'm probably wrong, but let's just change the value. Double click on it, change the value to 60. I'm right. This is our health address. We can modify our health. Great. What's gonna happen if we close the game and restart it? The health's gonna go away. Why? This pointer is is dynamic. So Windows has a thing where safety precaution where certain memory is dynamic, which means that it's going to always be different addresses when you restart the game or restart your computer. How do we fix this? Well, this health is a part of our player. Now our player has a structure or a class. Sorry, it has a class. Player has a class. Don't know what class is? Look it up. I don't want to explain all this, by the way. Like, I don't want to explain class and all that because they are basic terms you need to know when doing, computer science. So, I don't want this video to be hours long. So yeah. Am I even still recording? Yeah. Okay. Anyways, we need to find this player class because this player class contains the health, and this player class, if we can find the player class, it's always going to be in the same situation or the same place because the player class is going to be a pointer from the game base address. And the game base address is basically where the game is stored in memory. That's your base address. Then the class is going to be a pointer from that base address, and it's always going to be the same offset. So the base address is the one that changes, but the offset is the one that's going to stay the same. So you're always going to be able to find it because while the base address has changed, it's always the same offset away from the base address. So let's find something that we can identify where health is. So we're gonna find the static player class because the player class is gonna be where the health is stored, which means that if we find the static version of that, we can always access the health. So let's do that. Right click, find out what accesses this address. Hit yes to detect the debugger, and let's go take damage. So let's just throw a nade. Alright, grenade just went haywire. We're gonna take damage. Okay. Now this might look a little intimidating, but this is basically assembly. So assembly is going to be this is going to be your assembly. So assembly is the language that is readable by humans that is changed to binary by a linker. But so this is the stack, and here we have opcodes. So these are just opcodes that are accessed every time. But here is going to be what we want to look at. So this is telling us, so MOV sounds exactly how it sounds, move. It's moving, and then you think that it's going to be moving this into this, but it's not. So it's going to be moving EAX, which is this, which we can see in the stack. So it's just referencing something on the stack, into this address. So EDX plus 000 EC. Okay. So what is EDX 00 EC? So I'm going to make an educated guess and say that because we're adding stuff here, EC is the offset of our health, EDX is our player base. We're adding our health offset to our player base in order to get our health. Or adding a offset to our player base. So if we go to EDX right here, we have this value. So we're going to copy this and add it. And let's, in order to check, if we just do plus EC, there we go. We get 7, which is our health. So we now know that this is our player class. And we can view this even further by clicking on memory view, going to tools, dissect data structures, going to structures, define new structure, or sorry, paste in this, or the address. We'll define new structure. We'll say player ent, hit OK. Here we go. We now have everything in the play. We can look, and there's stuff like position, and if we go to EC, it should say 7. Yep, there we go. There's our health. So now that we know this, we have to find the static version of our player structure, because this will change if I restart my game. And I don't want to show you because it's going to take a long time in order to get that. So we're going to go ahead and copy this address here. And we're going to start a new scan with this address. And hit first scan. And put it, or we're going to change our scan type, or our value type to wait, let's just put in hex and then paste it and then hit first. Sorry. And now we have all our addresses. So you might notice some color coding here, and white means dynamic, green means static. So here are 3 static variables, right? And they're all different. Now, typically, we'd want to choose one closest to the entity list. For the demonstrative purposes today, we're just going to double click on the first one, and yeah. So now we have this value, right? And this is going to be this is going to be how we get to our player base address. And if we click on pointer and we add a value like EC, you see how we get 7. So we get our health. So now we have an easy way to get our health. We can also do, actually we can't because this is a pointer. But we now have our static address. Okay, that's basically the main purpose. And like I said, we can click on any of them. So like we can click on this one to do the same thing. We still get 7. So we're gonna grab the top one. And now we're gonna go ahead and take this address and access it. So now that we have this address, we need to learn what AC client is. So this is the base address I was just talking about. That's what AC client is, and this is the offset of the base address. Offset of the base address. So if we add this to AC client, we get our player entity structure. Simple. Okay. So how do we define this in code? So in order to define this in our code, what we need to do is we need to make a variable of our base address first, right? Now we can do this by going to our main thread and defining keyword module base, and we're going to set this equal to, we're going to cast this to a D word, and then we're going to do the function I was talking about earlier, just get module handle, and we can actually just throw in null here if we wanted to, but I am going to put the name just for safety purposes. because it will and here we go. It says that this is incompatible because it's gonna probably have this. No, wait, yes, okay. So make sure to go here and change the character set to multi-byte and then apply. If it gives you an error. Okay, so this gets what we need here. This supplies this part of it. So now if we just add this, we can get our player entity list. So yeah, this is just it. This is it. So now we can do, by the way, the reason you can put null there is because it's basically it gets the module handle of the injected parent anyway, so but we'll just do this and just to be safe. So now if we create a pointer, so we're going to use uint pointer underscore t, and this is a uint pointer is just an int is 4 bytes, so it's a pointer that is a 4-byte pointer, and make sure to put the pointer symbol at the end to identify it's a pointer, and we're going to call it local player equals, and we're going to cast whatever we put to a uint pointer t pointer. And it's also important to know that if you just put this and don't put a pointer symbol, this is just a type. This isn't a pointer. This is literally just 4 bytes. Okay. So and then in here we're gonna put our module base, and then we're gonna add this value. This is gonna be our offset, and this is our player. So now we have our player, right? So now the way we got our health is by adding the EC that we got from that we found earlier. We found EC earlier. If we go here and we go to player ent, you can see if we go to EC, this is where our health is. This is where our health is located. We gotta put this in here. Here we go. Go to EC. This is where our health is located. I see it's 7. So we're gonna add EC to it. Now, if you do this, it's not right, and I'm gonna explain why it's not right. This is not a valid, because we're adding this is adding EC to, we can't add memory, because EC is just a value, right? EC isn't a memory address. You can't add two memory addresses together. So what you're doing practically here is corrupting the memory. This is going to crash your game. So what we need to do is dereference local player. So this is how I kind of think about it. We are stepping into the player class, right? Right now we just have the address of the player class. We need to step into the player class in order to find the health. So we're going to dereference local player, and we're going to make this uint pointer underscore t pointer health equals uint pointer underscore t pointer, and then plus EC. Okay, this is now our health. And because we're actually internal, if we just do health equals 1 or 6969 and end it, this is perfect. This will work, right? And if we go ahead and convert, of course, health to an int. And we need to dereference health because we just have the address of health. Don't have to convert it to an int. Just dereference health. So that's just another thing. You basically have to dereference everything because we're stepping into it. So we just stepped into the player class, and then now we're just stepping into the value of health, right? Because we wouldn't add, like, think about it. Think about it this way. We wouldn't add like think about how we add for the address, how we change the value to 7 instead of changing the address, adding 7 to the address, because that's just gonna give you this. Okay, so if we build this and inject it, our health is going to become 6969. and I'll show you. Wait for this to build. Inject. There we go. 6969. And if we restart the game, it will still work because it's static. Okay. There we go. We've now created our first cheat. So yeah, I hope you guys enjoyed this video on how to go ahead and modify in-game values and find a static address. I will make another video talking about going into functions and stuff and how to do that. So stay tuned. And yeah, I hope you guys enjoyed the video. Peace.